Welcome to the Explainer. You know, computer networking is kind of like the invisible magic that makes our modern world tick. So over the next few minutes, we're going to make it visible. We're breaking down the 5 core areas that every single pro in this field has to master.
So to really get a handle on networking, you got to know where the real work is. The whole field is basically broken down into these 5 key domains. And what's wild is that almost a quarter of the job is just troubleshooting, just fixing stuff when it breaks. That's even more time than is spent on the basic concepts themselves, which really tells you just how hands-on and dynamic this whole world is.
Okay, so for this explainer, we're going to follow the life of a network, from start to finish. We'll kick things off with the blueprint. Then we'll get into the build, check out the daily operations, talk security, and then wrap up with the fix, because something always needs fixing.
All right, let's jump right in with our first section, the blueprint. Every single network, I don't care if it's huge or tiny, it all starts with a set of fundamental rules. It's like a common language that everything uses to communicate. These are literally the laws of our digital city.
Every network pro thinks in layers, and it all comes back to this right here, the OSI model. This is the universal language for figuring out what went wrong. When something breaks, a pro doesn't just ask, what's wrong? Nope, they ask, what layer is the problem on? They'll start right at the bottom with the physical cable and work their way all the way up to the app you're using.
So every device needs an address. But here's the thing, not all addresses are created equal. Think of a public IP like your home's mailing address. There's only one in the entire world. But inside your house, all your different devices use private IPs, kind of like room numbers. That separation, it's the absolute bedrock of how we organize networks and keep them secure.
Data doesn't just move in one way. When you're browsing a website, for example, that's a direct one-to-one conversation called unicast. But let's say you're streaming a live concert. The network is smart enough to send one single stream to tons of people at once. That's multicast. And really understanding these different flows is totally key to building a network that actually works well. Okay, so we've got our blueprint. Now it's time to actually build this thing. This next part is all about implementation. It's how we take all those ideas and concepts and start laying the digital roads that connect our entire city.
And these are the physical nuts and bolts of our digital city. You've got routers, which are like the traffic cops at the big intersections. Switches are directing traffic on all the local streets. Firewalls, those are the security gates. And the cables, well, those are the actual roads that all the data travels on.
So how does data actually find its way across this city? Well, you've got 2 main choices. With static routing, you basically program a fixed map into the system. But with dynamic routing, the network is alive. It uses these protocols. You might see names like OSPF or BGP, which are like the GPS of the internet, to automatically find the best way around traffic jams and outages. It's pretty cool.
And of course, we need wireless. I mean, come on. Setting up Wi-Fi is really all about carving out your own little private space in the public airwaves. You have to pick a frequency that's not too crowded, give your network a name, that's the SSID, and most importantly, you lock it down with encryption so that only the people you want can get on.
So once the network is all built, you can't just walk away. The real work is just beginning. Our third section is operations, and it's all about the daily grind of managing and maintaining everything to keep our digital city up and running 24/7.
You literally can't manage a network without a map. Actually, you need 2 maps. The physical diagram shows you where a device is physically located, like which shelf in a server rack. But the logical diagram, that shows you how the data actually flows through it. You absolutely need both to see the whole picture. When disaster strikes, the very first question is always this: how much data are we willing to lose? That is your recovery point objective, your RPO. Is it okay to lose a whole day's worth of work? Or can you only afford to lose 5 minutes? Answering that one question defines your entire backup plan. The very next question is all about time. Your recovery time objective, or RTO, is the deadline. How long can your website be down before your business starts to really suffer? An hour? A day? That decision dictates exactly how much money you're going to spend on backup systems.
And finally, there's MTTR, mean time to repair. Now this one's a little different. It's not a goal you set. It's more like a report card for your team. It measures how long it actually takes to fix something when it breaks. And trust me, trying to get that MTTR number lower is the constant challenge for any operations team.
Of course, a city that's running perfectly is, well, a target. And that brings us to our fourth domain,
Security. Think of this as the police force, the guards at the gate, all the things protecting our digital city from constant threats.
At its heart, network security is just this constant balancing act between these four things. A threat is some potential danger out there. A vulnerability is a weakness in your system that can be attacked. An exploit is the actual method someone uses to attack that weakness. And risk, well, risk is just the overall chance of all that bad stuff actually happening.
And believe me, the threats are endless. This list is just a tiny fraction of the attacks networks have to deal with. They range from just brute force things like a DDoS attack, which just tries to overwhelm a system with traffic, to really sophisticated social engineering scams like phishing that trick people into just giving up their passwords.
You know, there's no single silver bullet that solves all security problems. It just doesn't exist. The only strategy that really works is layered defense. It's about combining things, hardening your devices, making people prove who they are with multi-factor authentication, and using super strict rules, called access control lists, or ACLs, to make sure data only goes where it's supposed to go.
But look, no matter how perfectly you design, build, and secure a network, things will break. It's inevitable. And that brings us to our final and maybe most critical section, troubleshooting.
This number pretty much says it all. In the professional world, a full quarter, 24%, of the knowledge you need for a major networking certification is dedicated purely to troubleshooting. That really highlights how critical this skill is. It's the biggest single domain for a very good reason.
Real pros don't just start randomly unplugging things. They use a systematic, scientific method, kind of like this one. They figure out exactly what the problem is, they form a hypothesis, a theory about the cause. They test that theory, and only then do they put in a fix. And they always make sure it actually worked and write down what they did for next time.
And this, right here, is what separates a pro from an amateur. Yep, the problems can seem incredibly complex, but 9 times out of 10, they trace back to a simple, fundamental mistake. Someone used the wrong cable, there's a typo in an IP address, or it's just plain old wireless interference. The real skill is finding that simple cause fast.
And that brings our whole journey full circle, doesn't it? We've looked at the blueprint, the build, the daily grind, the guards, and the fix. So the next time you just casually load a web page, take a second and think about that invisible, non-stop cycle. How do these 5 completely different domains all work together perfectly in sync just to deliver that one page to your screen? Kind of amazing when you think about it.